question, the motor turns gear A. So the gear A is turning with a constant angular acceleration. So this is the constant angular acceleration. So if you write this down, this is constant angular acceleration, and the next thing which you have to do is starting from rest. So initial velocity or initial angular motion is 0, so it is starting from rest. This is important. The cord is wrapped, so this cord is wrapped around this pulley, and this block moves upward. If this is moving this way, the cord is wrapped around the pulley D, which is rigidly attached to the gear B, and velocity of the cylinder and the distance it travels in 3 seconds. So you have to find out the distance. Suppose it travels from here, position 1 to position 2. What is this distance? This is one thing which you have to find. The second thing which you have to find, the velocity of the. So what should be the velocity of this point C? So the approach which I would start with to find out the velocity using some formula. So I'm going to show you this velocity can be found. Look, velocity of point C equals to starting velocity plus acceleration. This is a linear motion because the block is moving upward in a linear fashion. But we do not have AC. How do you find out AC? Although initial speed is given, which is 0, and time is given, which is 3 seconds, but acceleration of point C is not given. But let me show you. If you take a look closely, there is a meshing point. Always start from the meshing point, because the velocity at the meeting point of the two gears is constant, or this is same for both gears. So can I write down like this? So look over here, can I write down like V equals to RA omega A, or let me write down here with this formula, acceleration, linear. Let's start from linear acceleration of point A. Velocity is also common, and linear acceleration, which is tangential acceleration, alpha R. It is same at the meshing point. For the meshing point, which is P, so can I write down a acceleration tangential of point P, or whatever you want to like. So can I write down alpha A R A? It is the same at the meshing point, alpha B R B. Can I write down like this? And we have been given some information. For example, look over here, this is the radius of gear B, radius of gear A, and angular acceleration of gear A has been given. So let me complete this equation. So let's do this equation here. So I'm going to write down alpha B. Can you find out alpha B from here? Alpha B equals to alpha A RA over RB, and alpha A is given to us 4.5, and RA and RB, it doesn't matter right now, it's in the dimensionless quantity, so it doesn't matter whatever units are. So I'm not gonna change the units from millimeters to meters here, because it's gonna cancel the numerator and denominator. So RA is 75, RB is 225. RA is 75. So if you do the math here, 4.5 times 75 divided by 225. So this is the angular acceleration of gear B, which is in radians per second squared. And once you know that gear B has a pulley. It has a pulley which is wrapping the cord up. When the gear moves, the pulley also moves with the same acceleration. Angular acceleration of gear B is same as that of angular acceleration of pulley. Angular acceleration B equals to angular acceleration D. Angular acceleration. How do you relate angular acceleration with a linear acceleration? We know that angular acceleration and linear acceleration are related with this formula. So if I want to find out AC of this block, so that is equal to A tangential of this point D, which is the disk or the pulley, I would say, and it has 125 millimeter. The radius of this disk or pulley is 125 millimeters. So now I would do the math because I need to convert it into meters now. So alpha D RD 1.5, RD is 0.125. So if you do the math, you should get 0.1875 meters per second square. Now this is the acceleration of block C as well, because they are all linked. You see my point? Now we have found the acceleration of this equation. This equation, we wanted to have the acceleration. Now let's plug it in. In this equation, I'm going to write down the same equation to find out the final velocity after time 3 seconds. So I'm going to write down 0.1875 times 3. So you get 0.563 meters per second. And this is going up because we are assuming this is positive upward. And how about the distance? The distance which we can find out by the distance formula. It is now the simple linear formula. You remember this linear acceleration or linear distance formula? This formula, I'm going to use this equation. Use this equation to solve for the distance, upward distance for this block. So I'm going to use this over here. So let's plug it in everything. So we want to find out the final distance of this block moving upward. Initial distance is 0. Initial velocity starting from rest, half. Acceleration is point. So if you do the math, you get 0.844 meters. So this is your answer.